So multiplication and division of inequalities, you must be really careful with. Okay, you have to think it through. In some ways, the most important thing, the biggest tip I can give you, is make sure your inequalities are always facing in the same direction. That will save you from a lot of, number one, confusion, right? And number two, just getting results wrong because it looks all okay, right? But having everything chopping and changing, things that you can do when the inequalities are in the same direction, you cannot do when they're in different directions, okay? So trying to make them as similar to equations, as you can, this is what you want to have, right? Okay, I need another color. Now, how are we going to start to work with these? Having these inequalities here, the really important part of them is the relationship between A and B and the relationship between C and D. Okay? The fact that it's got these zeros on the end, what does that tell you in addition? Just tells you that everything is positive. Okay? So in some ways, what I'm really looking at is this and this. Okay? Now I've got to somehow translate those into these. Okay? So the very first thing I'm going to do is if I just take those two, let's name them, shall we? Let's call this one, just that, these two together, okay? And call this two, just those two together. I'm going to multiply them, okay? Now here's what I'm going to write down, and let's think about it before we move any further, okay? Before we just take it as a truism, right? If I say 1 multiply 2, okay? Being that my inequalities are facing the same direction, I'm going to say AC is greater than BD. Now let's just pause and make sure this actually works, okay? Put in, even think of some numbers for yourself that you can put into that would satisfy these inequalities, right? And is this statement true? A and C are my bigger numbers, okay? Out of A and C, I don't know how they relate to each other, okay? But each of them is kind of like on the big half of them, whereas B and D are smaller. So if you multiply two numbers that are both bigger than these other two numbers, the products are going to retain this same inequality, okay? Does that make sense? So this is actually, this result going from here and here to here is a property that you will have to use in the future, okay? So, all right, now that we've got that, how am I going to get from something like this, which relates all four of the numbers together? That's why it's useful to me, because this inequality does as well. How am I going to get from here to here? These are products, and these are ratios. Well, I'm going to have to divide by something, but my question is, what shall I divide by? Look at it carefully. Now, I'm going to recommend, by the way, in these, yeah? Good. In these early steps, these early days, what I recommend is for your own sake, right? Write down what every step that you go through is to transform one line to another. Okay? With equations, you can kind of play fast and loose with them, but when you're doing inequalities, right? For instance, when you divide through by CD, you have to know what properties C and D obey to know what happens to this inequality, what direction it faces. Okay? Okay, so if I divide through by CD, I'm going to write out the full step. Okay? I'm going to get this. Okay? Now the inequality is facing in the same direction. Now again, not because I have to, but because it's useful to me, I'm going to note down that this is true as CD is greater than 0. Okay? I know CD is greater than 0 because C and D both individually are greater than 0. Okay, so therefore their product also must be positive. Right? Okay, now that I do that, I can cancel the C's and then cancel the D's. Okay, so I've got A over D being greater than B over C. Okay, so this is good. It fits in with what I'm trying to prove. Just watch out, the inequalities are backwards. That's why they're the other way around. Okay. But I'm missing this thing in the middle, okay? So this is true, but not sufficient, okay? So how can I sort of wedge this guy in the middle, right? Well, what I'm going to do is I'm going to come back to this line, okay? This line's really critical, so I'm going to name it so that I can work with it, okay? So if I have a think about 3, right? If I want to get these and sort of go towards something like this, I've got to get this weirdo ratio in the middle, okay? Obviously, just simple multiplying and dividing will not get me there, okay? Because as much multiplying and dividing as you get, you'll never have a plus sign in there. So I need to add something to both sides and then do my dividing, and then I can get my ratios. The question is, what shall I add? Now think about this carefully. What you may like to do is get a pencil or a different color and do this off on the side, okay? This is usually a big no-no in terms of actually proving, like setting out your proof, but it's still useful in terms of, okay, we're working out what steps should I do. Let's have a think about this left-hand part of the inequality. Okay, so I'm just going to write it over here. And I'm just going to work with it for a second, okay? Now the reason why you can't do this in the main body of your proof, okay, in what you actually submit as your answer, is because in order to work with this, I'm assuming it's true, right? So as soon as you've done that, it's over, okay? Any conclusion you draw from here will not be useful for an actual proof because you've assumed that it works, right? Yeah. You can do proofs by contradiction. I think in this case, it's a bit overkill because it's actually, algebraically, it's quite straightforward to get through, okay? But all I'm going to do is go from here and see if I can notice some insights about how this, what endpoint I'm trying to get to see how I should muck around with the equation 3, inequality 3. Right. Okay, so like I said, this is a ratio. It's a bit hard to work with though. So let's turn it into products, okay? So I'm going to multiply through by C and C plus D, okay? So multiply through by C plus D. So it's sort of like cross-multiplying, right? But you got to be careful because they're inequalities. It's not quite the same as in the equation. Now, seeing as both of these are positive, C is positive, C plus D also must be positive, inequality stays the same, right? So what I'm going to get is this. That's fine. Okay. So now if I expand, I have this. Okay, now look carefully at this line, right? What's the parallel between this and what I've got here? Where are the common elements? I've got my AC and my BD, right? Yeah, you can see it. I've got AC and BD here, and then I've got this BC on both sides, okay? So now you can see, well, if I don't know that this is true, I'm just imagining if it were, okay? So let's go back into a real color, right? I've established this, I've proved it, okay? So I'm gonna say, for equation 3, right, let's add, what was my common thing? BC, I'm gonna add it to both sides, okay? So now I'll get this. Okay, you see the difference in what I've done? It's kind of like, this is the trick that you might use for a trig identity proof, which is just like, I can't see what's going on here. I have to add something and subtract it from both sides, but I can't see what it is. This is what you do to work out what you have to add and subtract. Okay. Now I can factorize. And I'm really just rehearsing the steps I just did, but backwards, yeah? Okay, now to get from here to what I was trying to work with, I'm going to, instead of multiplying through, see this is why it's so useful to put down your steps, right? I'll divide through by that, okay? So I'm going to end up with, which way do I want it? Let's see, this over here. Okay, now, I do need to justify here why my inequality hasn't changed direction, just like here, okay? So the reason I'll say is as C is greater than 0, and C plus D is also greater than 0, okay? Sometimes in some proofs you might see it written because like they might divide through or multiply through by lots and lots of different things. They might say as all factors are positive. Okay, because that's what they're really doing, right? They're just noticing this is positive, so inequalities stay the same. Okay, good. Now you see this is the left-hand side.
Can you do the
right?
same thing?
Now, I can do the same thing for the right-hand side, right? I just want to go the other way. So I'm going to have to add something different so that it factorizes in a way which will give me this side of inequality and not that, okay? So without doing this step, right, and just guessing, right, do you think you could work out what do I need to add to both sides of 3? I'm going to start with 3 again. What do I add to both sides? Now, I'll give you a tip. We wanted to have B on C here, right? So it was going to be our factor. That's what factored out, okay? So in order to have that as a factor eventually, I had to add BC, right? That was the common factor on both sides. Now, what I want is A over D, so therefore that makes you think, okay, instead of adding BC, I should add AD, okay? So I'm going to get AD plus AC is greater than AD plus BC. Have I done that right? Sorry, that's wrong. That should be BD. Okay? And just like before, I can factorize. Okay? And then I'm going to end up with this fraction on this side, a plus b over c plus d. And there's my a over d. Okay? So now, let me draw it all together. Yeah, question?
That mean we didn't actually have to do the first bit then?
You mean this part here? Yes, absolutely. Now, the reason why I put it in there is because it's the first thing you would guess, right? Because normally I'm thinking, okay, the shortest path from here to something related to this is this, okay? But that's why I noticed that it was insufficient for my proof, okay? And you can see, let's name them so that I can put them together. I guess I'm up to 4 and 5, right? I will now say from those two equations, not any others. Inequalities. I don't need any others to draw my conclusion, right? I can say, I'm now changing it so it's smallest to largest. Ta-da! Okay. So, couple lessons to learn, right? Number one, be insanely careful about the direction of the inequality, okay? The direction of the inequality is everything. And secondly, when there's one of these kinds of tricks involved, you've got to add something to both sides, but what is it, okay? Think about what you're required to prove, but do it separately. Please do not include that in what you're actually proving, okay? Because as soon as you've done this, it's a big no-no, okay? And a lot of people did similar kinds of things with trig in the exam that just passed. You have to prove an identity or prove that something was equal to some value, right? If you assume this is true and then work with it, your proof is automatically invalid, okay? Yeah?
Wait, so generally, in what case can you simplify both sides?
T results. And that's basically it. With any other kind of thing, if your approach is to try and work out what to do, you simplify from both sides, right?
Like that's still technically the same thing, right? Because
yeah, that's right. If you aren't transferring anything over or doing any operations to both sides, like say squaring, which assume that it's true, anything like that, multiplication, division, addition, subtraction, they're all fine. So yeah, okay.